that we did yesterday. Actually practice. Hi, Haley. So get to the point where you've got your notebook probably first, because we need to adjust this formula, and you'll want to have that somewhere in addition to the work that we did yesterday, so you can look back at it. But then we'll practice with the ones that are on. So. The more you guys ask, the less likely it's ever going to happen. So, that would be nice. The problem is it's Wednesday. One day, maybe. We'll see. One day. I said next week. Let me get ready to go here. Now I feel ready. Now you guys can take me seriously. No, man. Listen to that test, right? You say that makes us take you seriously? This is my team I play for, Denver. Denver Hops. We're the minor league team outside of Portland. The Hops. We're being named the Hops. We get breweries to sponsor us. We don't have to pay as much, which is kind of nice. All right. So, we've been talking about this one for a couple days now. So we kind of built that formula, and it works pretty well if it's just percent growth and decay. But the reality of that formula is it doesn't really work as well with like how banks calculate interest when we're talking about money. So I want to take that formula and just make a tiny little adjustment so that it makes more sense. So that it's actually just more realistic in terms of what the answers are going to be. So wherever you decide to write, it's up to you. But you want to have it somewhere where you can go back to it. Tomorrow, when I actually hand out some stuff where we can practice with it, the first thing you'll do is you'll write it down. So it's kind of nice to have it written somewhere. Like I said, percent growth and decay is good when we're talking about percents. But with interest, right? With banks trying to pay you money and you wanting to kind of make the most money from that, the reality is that it happens a little bit differently because the rate that they talk about is always an annual one. Now, you're going to make this much per year, but they're not paying you once a year. They're going to pay you more frequently than that, usually once a month. So I want to give you an example that I think will help us come up with the small changes that we need to do to this one to get there. So just so that it's on camera, I'm going to rewrite it over here again. No, you're good. Go for it. So I'm just going to rewrite that same formula over here for percent growth and decay. You don't have to write it again. I'm just going to. And then we're going to adjust it to become a compound interest formula. And I think this example will help us come up with this formula really nicely. You're going to see how similar it is. We just have to add one thing in there. And so I want to have this make as much sense for you as I can. So here's kind of the example off to the side that we'll do that I think will get us there. Again, this is only for interest with banks, okay? But it comes from the same formula, which is kind of nice. The setup that I'm going to give us that I think is going to help us out a little bit. Let's say we start with $100. This is a nice, easy, round number to think about. And they tell us that we're going to get, and I'm picking this number on purpose, a 12% annual. Sorry, I should put that. Let's put that word there. Annual. Two ends, right? That just looks weird. Words are weird. Annual interest rate. But we're not gonna just wait until the end of the year to get our $12, our 12%, right? They're gonna pay us every month. And And so the way to say that, like how often we get paid, we're going to say it's going to compound monthly. Okay, so it's a 12% interest rate, but I'm going to get paid way more frequently than that. Okay. And of course, we're always going to start with our model, and that's going to help us get there. So I'm still going to call it A of T. Okay, cool. The setup is like that, and I pick nice, easier numbers, so I think that's going to help us out a little bit. If we're getting 12% for the whole year, but they're going to pay us out once a month, those numbers should work out nice. But the interest rate, how often we get paid, does that have anything to do with the amount that we started with? No, those are unrelated. So it's still going to be P. It's still just going to be that 100. Like that can't change, right? Our A, right? Our P in this case, our starting amount doesn't get affected by what the rate is or how often we get paid. It's still going to be a place to begin. And it's still going to be just the number one. You know, I'm going to have that little one after it, right? However you want to write your ones. This is too heavy. Hurts my head. All right, now this plus or minus. Put money in a bank. We're leaving it there. They're paying us interest. Is that ever going to be minus? No, it's always just going to be plus, right? And so with like percent growth and decay, yeah, we had to pick whether it was going to increase or decrease, appreciate, depreciate. Interest is always just going to be plus because money's going up, which is nice. All right, cool. Here's where the changes start to happen. If we're getting paid 12% for the whole year, but it's going to happen monthly, what do you think our interest rate is going to be every month? So we're getting 12% over the whole year. Like that's an annual rate, but they're going to pay us out monthly. You think we're going to get 12% every month? No, what do you think we're going to get paid every month? 1% over the 12 months, right? Okay, well, don't write this, but just so you can see it. What if it was 24%? What do you think we would get every month? 2%, right? The 24 kind of divided evenly over those 12 months. Okay, what if it was 36? 3%, right? And so what are we doing to the rate every time we kind of adjust it according to this? We're dividing it evenly. So let's go back to that 12%, right? So rate as a decimal, 0.12. But what has to happen, so our rate, we have to divide that by something. And what we're going to divide it by, so everything up to this point is the same thing. P is principal, R is rate as a decimal. What we have to keep track of is this. How many times we get paid out is going to play a role in how much we get over and over and over again. Okay? The number of times that we compound our interest. And when I say compound, I just mean like how many times are we going to split it up evenly, but we're going to get paid that much more frequently. And so there's a lot of words in there. The number of times we compound our interest, right? So that's going to go right here. The number of times we compound interest. So if it's monthly, it's 12. If it's weekly, how many weeks are there in a year? 52, good. So that number would be 52. Daily, how many days are there in a year? So this is per year. 365. Actually, realistically, it's 365.25 because of leap year, right? We had to add a day there. And it's actually like 365.24973. It's like almost I'm just going to call that n. Okay? So I'm going to divide by whatever this, like however much this happens within a year. So monthly, 12, weekly, 52, daily, 365, quarterly, 4, right? Semi-annually, 2, right? So there's a lot of different ways that we can compound our interest depending on how frequently we want to do it. Okay? But here's the thing. If I'm going to divide this rate by n, so I'm like chopping my 12% up into like nice 1% increments. If I just put t up here, that means I'm only getting paid that one time. If t is 1 year, I'm only going to get paid twice if it's happening 2 years. I'm only going to get paid 3 times if it's happening for 3 years. I want to get paid monthly for a year. I want to get paid monthly for 2 years. I want to get paid monthly for 3 years. So think about it. If time is just 1 year, how many times should I get paid? 12. If time is, that's so loud. If time is 2 years, right? So let's say we go out and just leave the money in the account for 2 years. How often, how many times should I get paid if I'm doing 2 years monthly? 24 times, right? 3 years, 36. 10 years, I'm going to get paid 120 times. So if I just leave this as t, I'm not getting paid the way I want. I got to make sure that I'm getting paid as often as this n is telling me I'm supposed to. So if we're going to divide this rate up by n, like it really kind of like decrease how much we're getting paid, I want to make sure that I'm getting paid that much more often. Does that make sense? And so don't just leave this as t. We're actually going to do n times t. Okay? And that is your compound interest formula. So the only change that we have to make is like getting that n in there, but it shows up twice. Okay, we're going to divide our rate up by that much. But I want to make sure that my exponent has that same n in there being multiplied through time. Because you could probably say, all right, $100, 12%, cool. At the end of the year, I should just make $112. But if we actually do this, right, let's go out for 1 year. Let's see what happens after the year. 12% interest annually, but it's going to compound monthly. Let's try it. 100, 1 plus, and I just leave it. I got to bother like actually dividing this up. 12 times 1, which is just 12. Here's my phone. Let's take out a calculator. Let's calculator do the work for us. Let's see what we get. 100. Oh, let me go sideways. Oh, you know what? Let me just use calculate 84. It's easier. Calculate 84. I'm just opening up my calculator. 100 parentheses. And just type it exactly as you say it out loud. 1 plus 0.12 divided by 12. Back it up, delete. 100. 1 plus 0.12 divided by 12 to the power of, now in my phone, when I go up to the exponent, it like moves me in. So I can just type 12 times 1. If you're in an older like handheld calculator, like a TI-83 or an 83 plus, you have to like use parentheses to be careful. So I'm just going to write the number 12 because I know that's what that is. Right? 12% interest on $100 should just be 112. But look what compound interest is. Now I know it's not a whole lot, but I will take that extra 68 cents if you're going to use it. And that's why compound interest is good for us. Because we're going to make more than 12% over the long term because we kept getting paid. Right? I got 1% after January. All right, cool. So now it's $101. And now I'm getting 1% on that. Not on my original 100. I'm going to get up 1% on $101. And sure, all right, fine. It's an extra what? It's an extra penny, right? Or whatever it is, an extra 10 cents. I'll take it. If you're going to pay me more, I'm going to let myself get paid more. But it does work in both directions, for sure. When they calculate interest on your loans, right? You take a student loan, a car loan, a house loan called a mortgage, right? They compound interest as well. So banks are definitely going to use this to make it look like they're being more generous to their consumers, which they are. They don't have to do it. They choose to. But they're going to compound interest on their loans as well. And 12% is a ridiculous number. I was actually looking this up during homeroom. We were talking a little bit, Adam and I, about interest rates and stuff. My savings account interest rate with Chase is 0.02%. Okay? I made 15 cents so far this year in interest. 15 cents. All right? Savings accounts are not the way to make money on your money. Okay? Not taking risk is not going to get you very far unless you've got big old buckets full of money that you're going to dump in somewhere. Okay? I've got a drop in the bucket. I'm trying to make that grow for me. But hey, listen, compound interest helps me out a little bit, so that's kind of nice. Cool. Let's do a couple more, and then we'll do number 9, and then we'll call. What time are we out of here? 15, right? Yes, we got a little bit of time. But that's it. Just small little change. Not too bad. Just got to get that N in there. But we have to watch out for that word. Monthly, weekly, daily, quarterly for 4. Semi-annually, or hey, the word annually means 1, and that's where it really just came from, right? This was 1. It was an annual interest rate. I got paid once a year, so dividing by 1, multiplying by 1 doesn't change anything. So that's really what's going on. We just take this percent growth into K formula and adjust it. All right, so call this one example 2. I don't know. What's up, Ash? Yeah, go ahead. Griff, give me a starting amount. Anything you want. 300. TJ, give us an interest rate. 8%. Cool. Now it's going to be annual. Then 8% annual interest rate. And Dylan, give us how often we want to get paid per year. Monthly, daily, weekly, anything. Daily, cool. Okay, so the interest is going to compound daily. Let's write our model in terms of T. That's always going to be the first thing we do. And then we'll answer a couple different questions based on how much time we want to give. Okay, so that was kind of this one, right? There's a model, and there is it after 1 year. Well, model in terms of T, always just 8. And just got to drop stuff into the right spot. Okay, compound interest just has that extra N in it, right? We used to just have principal and rate. Now we got principal, rate, and N, the number of times we compound per year. All right, so what's our principal? What are we starting with? 300. 300, there we go. And I'm not going to put the $sign in the formula. I'll just put it at the end once I have an answer. And of course, I rounded here. It was like 112.682. 2 wasn't big enough to make it 69 cents, so I just left it at 68. Okay, the number 1. Always, always, always. Because we know we're going up, I don't need plus or minus. I don't have to make a choice. It's just always. Now, in here, top of the fraction, good. 8%, so think $0 and 8 cents, so 0.08. Now we divide by the number of times we're going to compound our interest per year. Compound daily, let's just call it 365. We don't need the 0.25, we'll just call it easy. There's the inside. Okay, that's inside the parentheses. But close them off, it's exponential, so I need an exponent, right? And of course, that exponent is where the variable is going to go. But now, right next to it, this same exact number, right? You're dividing by n, but now up here, we want to make sure our time gets multiplied by that same n. So 365 times t, which is 365. You put the little dot in between if you want, There it is. There's our model, no matter how much time has passed. Mr. Smith, give us a number of years. 5. Cool. How much money is in the account after 5 years? And again, this is kind of going into like, I'm just not going to touch this money at all. They're going to drop in my interest. I'm going to get my statement like in the mail, or they're going to email it to me, or all I have to do is jump onto my bank account online, and I can watch the money go up. Yeah.
Divided time is answered by 5 or no?
No, because what's happening is we're getting paid that much, that like more often. We're getting paid every single day for 5 straight years. They're going to give me 0.08 divided by 365. They're going to give me that much percent on my 300 every single day, over and over and over again. This formula does it for us. All we have to do is change that to 5. 365 times 5. So it's not that I take this and multiply by 5. I just put it up in the exponent. Now, we got to be careful with those exponents. The app does a really nice job because I don't really have to worry about it. As soon as I press that up arrow, it moves me up into the exponent. 300, it's just calculator stuff. 1 plus 0.08 divided by 365 to the power of 365 times 5. It's money, so we got to round to 2 decimal places if necessary. Most of the time it's going to be, because we've got decimals being divided by big numbers and then up to crazy exponents. Like 365 times 5, like that's huge. That's a humongous number, right? That's almost an exponent of 2,000. That's crazy. That's how many times we're getting paid. Adam?
So t just finished the phone, right?
Exactly. Yeah, so it's the same t as it was here, just number of years, right? And here's why it's number of years. Because our rate was an annual rate. We're just getting paid more often than that, which is nice. Our money gets to make money for us. I got, let's see if you can get the same thing, 447 points. That was 527. So 53. Yeah, we're going to round up because that next number was 5 or above. So after 5 years, right, we got 8% annual interest. But over a course of 5 years, so that should be like 8 times 5. That'd be like 40% interest. We actually almost got 50% because of compounding. Right? I made almost like on top of my 300, I made almost half of that, right? 300 turned into almost 450. So 8% interest for 5 years should be about 40%, but because it was compounded so often, we made almost 50% of our money. That's great return. Okay. Let's do one more with this example. How much money is in the account after, I don't know, Paige, pick a number much bigger than 5 years. Let's see, 30 years. Nice. My goodness, you guys are going to be so old like 30 years from now. Not so young and handsome. Let's do it. So nothing really changes except the 5 turns into a 30. Remember, it's a of t, right? So t is just time. So whatever number they give us, we just drop it in. Right? So 300. 1 plus 0.08 divided by 365 to the power of, and again, that same 365, but now times 30. don't know. It's got to be grand, right? Let's see. 300. One
More than that.
Is it more than that? Divided by 365 to the power of 365 times 30. Whoa.
Mm-hmm.
Ooh, find me this account. I'm in. $3,306 and 0.083. So 0.08.
Round it up then?
I'm rounding to the nearest penny, not the nearest dime. Yeah, round to the nearest penny. So 2 decimal places means like you're either going to keep those 2 or you're just going to bump the 08 to an 09. But it's 0.083, so we keep it like that. And that's it. That's compound interest. Okay, good? Now do number 9 for me. Now that you've got it, see if you can do number 9. I'll do it with you. But I want you to try it on your own first. Yeah. Oh, from yesterday? That they're right where I left them. Here's one. Yeah. I did not. So I left it here to charge. And the thing that does not give me a whole lot of hope, that should be a green light to say it's fully charged, and after a day of charging, it's still orange. I haven't touched it yet though, so let's go through this together. It's a bad start. Now I'll actually take it home. I'll open up the back and see if I can.
All right. So this isn't like a whole percent top, it's 2.5. How would you make that?
Ooh, look at that. 2.5%. Well, let's think about it. So if it was 2%, it would just be 0.02, right? If it was 3%, it would be 0.03. We want to be in between those, right? 2.5%. Well, let me ask you this. If there are no numbers that I really need to write after this, what's the next decimal after that? No, like up here, like just 2%. It's a bunch of zeros, right? But I don't need to bother writing down here too. Okay. So what do you think that next number should be if it's 2.5%? So like that's 2%. I just don't need this 0 because it doesn't do anything. This is 3%. I just don't need this or any of these zeros. But 2.5%, we're just moving the decimal 2 spots. We just let the number just be. So if it was like 2.3%, okay, 0.023. We just need another number after this because we had 2 decimals. And you'll see the same thing with B, right? 1.75%. Let's do it. So this is 9. Now I'm going to do the model first, and then we'll plug in our number. Anyone? I got you. Right, so starting with 1600, and it says 3 years for all of them. So T is always going to be 3. Let's do our model first. A of T equals, all right, P is 1600. 1 plus 2.5%, so 0.025 divided by the number of times we compound our interest per year. This is A, 9A. What's that magical word in that setup for A that's going to give us that number? The account pays 2.5% annual interest compounded monthly. So what's this number? Well, 12 months in a year, which means that up here just goes 12T. Okay. Then we can plug in 3 and see. Right, so do the model and then plug your number. right, so do A of t and then A of 3 for each one. A of t, A of 3. They want us to do after 3 years for each one. And then you're done. Then we're good. And it's 1600, 1600, 1600. Same starting amount, they're just kind of messing with the interest rate and how often we get paid. 1 plus, 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 1 plus. Ooh, okay. So 1.75%. Well, just do like 1% and then throw a 7.5. So 1% would be that, 0.01, right? 1 penny. There's 1%. Well, I just want a little more than that. I want a 7.5 to show up after that. 0.017. Because remember, like, this is my interest rate, 0.02. Like, that's how much I'm actually getting. Divided by, ooh, okay. The account pays 1.75% interest compounded quarterly. 4 quarters in a dollar. Well, you paid 4 times a year. March, June, September, and December. Or, depending, not usually though, January, April, August, and October. Usually it's at the end of the quarter, not at the beginning. And that's to the 4t. And we just plug in 3. 4 times 3, which is, well, we made less interest and it was compounded less often. Number had better be smaller. We're not making as much money. We're not getting paid as often. So there it is. Same starting amount, less interest, less often, less money.
Sour compound.
Oh, yeah.
I tried to get Miss Rose to do it. She's like, no. She was the one that asked me to bring it in.
Really?
Yeah, you should do it. Take a spoon.
I'm good, thanks. I'm good. All right. Same setup, 1601 plus. All right, so the rate on top, right? R goes on top, 4%. At least we don't have the decimals anymore, so that's good. We have to change 4% to a decimal.
0.04.
Yeah, 4 cents, right? Yearly. What's N? But that's daily. How many years are there in 1 year? Yeah, it's kind of a weird thing to say if it's I'm only getting compounded yearly. N is really just 1, which doesn't change much. So it's really like just 1 times t up there, which is just t. So you don't even need to write the 1 times t, but just for good measure, I'll write it. But this is like, seriously, it's just 1 plus 0.04 to the power of 3. And you can put the over 1, you can put the 1 times 3, but dividing by 1, multiplying by 1 isn't changing much. And that's, that's percent growth. Thankfully, banks will pay you probably monthly. Right? We're at least going to get paid monthly if we're dropping money into an account for them, so that's good. Now, much higher interest rates, so I should make some more money here. I got 17.99, 17.99. And I'm good right now. No, I'm good. I had a big one. I'm good. Thank you. Plus at baseball, I see gold. That was funny. Which is just salt and fat and protein. I think a favorite flavor of seeds.
Dill.
Dill's good. Dill's good. Black pepper is probably my favorite. There's a sweet and spicy one. That's naughty. That's really good. Barbecue's good. Taco Supreme's really good. There just isn't a bad flavor. At least I think so.
I don't like the ranch one.
Ranch is a little weird. That's not my favorite. But yeah. But like, go to Coors Field, bring it back and see it with you. You like buy like a really big soda and you ask for an extra cup.
It just doesn't work.
All right, I'm good right there. We got about 5 minutes, folks. I know you guys are good. Any questions? You guys feeling okay about this stuff? It's tougher at home than it is here, but hopefully that sinks in okay with you. If you have any questions, let me know. Otherwise, I'm good. I'm gonna